Hello everyone. I'll just share my screen and then we'll get started. Take me just a moment. You should now be able to see the first slide. It's the title slide. I want to talk this afternoon about housing net zero carbon strategies for social housing and an assessment methodology for figuring out how to get your housing stock to net zero carbon. So first part of the presentation will be about what a housing net zero carbon strategy looks like, what an investment strategy for moving your stock to net zero carbon might look like despite current unknowns, and how to do it in stages and deal with fuel poverty and so on. And then secondly, I want to deal with a methodology for assessing your stock, current performance, evaluating improvement options, estimating investment costs, and so on. So let's start with the housing net zero carbon strategy. There are some principles that we need to adopt in order to be able to do this effectively at the current time. One is that we don't want to be making assumptions about things that are currently unknown. And those things include the carbon dioxide emissions factor for electricity in 2050. We have no idea. There are some projections that take it to zero and some that don't. We don't know how quickly it will be achieved. The characteristics and costs of batteries, which are probably a transformative technology in housing. The extent of penetration of low carbon heat networks in our urban areas in particular, and the extent, if any, of hydrogen substitution in the gas grid. And hydrogen looks like a very fragile technology for that purpose at the moment, so I wouldn't put much store by it myself. Second principle is to adopt an energy demand reduction strategy. We know that decarbonisation of the electricity supply and retrofit are not alternatives. It would be impossible to decarbonise the electricity supply and go all electric without demand reduction. Without retrofit, we would need 30 times as much wind power on the grid as we have today. And even with deep retrofit of all buildings, housing and other buildings, we would need 10 times as much wind power on the grid as we do today. So it's a big challenge. We also need to allow time for investment in the electricity distribution network, because if we're going to be moving our housing stock away from fossil fuels like gas towards electric heating, maybe with heat pumps, then at the same time as we're all converting our cars to electric vehicles, then we will actually overload the distribution network. So we need to proceed in stages, and we need, in the building sector, to prioritise the building fabric. And that's actually what's currently proposed for ECO4 funding. Third principle is that we should be focusing first on fuel poverty and then on emissions reduction. And there's a very simple reason for that, because coal households don't care about reducing carbon dioxide emissions. So the key performance indicator initially is SAP, because SAP is a cost-based energy rating, but it will be complemented now and eventually replaced by the environmental indicator, the EI, which is also part of SAP assessments. Fourth principle is that we should be adopting the fabric first approach, which is recommended by the new domestic retrofit standard, the comprehensive domestic retrofit standard PAS 2035. Publicly available specification 2035, and the fabric first approach says, first of all, improve the building fabric and ventilation to reduce demand. Secondly, decarbonise the building services and make them more efficient to satisfy that demand efficiently. And finally, use renewable energy technologies to top up to target performance. Fifth principle is establish whole house improvement plans, or whole dwelling improvement plans, if you like, for each dwelling type as required by PAS 2035. And the plan should identify your route to net zero carbon ready. So with those four principles, we start out with stage one, improving the building fabric to reduce demand. We need to improve the whole building envelope. We need to remember that there's no insulation without ventilation, and PAS 2035 requires ventilation upgrades when we insulate. We should be consistent with BEIS's suggested fabric-focused whole dwelling approach for ECO4, which has potential funding of up to 15,000 per dwelling. We should accept that some protected and traditionally constructed dwellings cannot be adequately improved, so other dwellings will need deeper retrofit to compensate. And we should be aiming at this stage for SAP 80 to minimise or eliminate fuel poverty. The current EPC Band C, which is SAP 69 to 80 target, is not really adequate because it provides no headroom, especially in an era of rising fuel prices as we expect to find during the 2020s. And we should be considering what standards we might adopt. I'll come back to that later, but with the best practice passive house ENERFIT standard might be one that we would consider. Stage 2 is to improve the building services and their controls with a focus on heating, hot water and cooking. We've already done ventilation as part of stage 1, and lighting has already been driven by EU standards. What we need to be doing is removing fossil fuels. So the options are individual air source heat pumps, perhaps electric induction hobs for cooking, communal ground source heat pumps for blocks and small estates, heat from low carbon heat networks in some urban areas. That's probably the most likely source of low carbon heat for many of us in urban areas. And then possibly hydrogen from the gas network where available after 2035. We should initially be considering moving from gas boilers to heat pumps through hybrids via a stage of hybrid heat pumps, which combine a gas boiler with a heat pump, because that will reduce the load on the distribution network, the electricity distribution network, and we can move after 15 or 20 years to pure heat pumps. We need to keep heat pump and domestic battery technologies under review. I think they'll both improve and become less expensive, and we ought to be aiming by the end of stage 2 to bring all dwellings to net zero carbon ready status. Stage 3, somewhere between 2035 and 2050, is to add renewable energy technologies to achieve net zero carbon. The provision we need to make will depend on the extent of grid decarbonisation. It may also be constrained by things like the available roof area. The options we'll have are solar PV with battery storage possibly, solar thermal systems for hot water because that will be the biggest thermal load by then. So it would be difficult to ignore solar thermal. And then community wind power, which is probably the most likely source of low carbon energy, either local or remote, or it may be that if the grid is completely decarbonised, we get it all from the grid. We may also require some solar PV for zero carbon active cooling. Overheating is the issue that's going to come back to bite us in retrofit, and passive measures, as the current advice advocates, are really not likely to be adequate. So we need to be aware that we might need to have some cooling demand in our dwellings, and of course cooling demand and solar power availability are very well matched. So a certain amount of solar PV on the roof driving a little cooling unit might well be what we all end up doing eventually. When we're implementing this strategy, we need to adopt challenging standards to drive progress. It is not easy to get to net zero carbon ready by 2035 or 40, and then to get to net zero carbon by 2050. And most of us won't be able to afford it, so there's a whole line of work around finance going on that we'll have to get back to. But we certainly ought to be adopting appropriate technical standards. And I would say that the first of these is past 2035 for quality assured retrofit. That includes a risk assessment, a whole dwelling assessment, an improvement option evaluation, and a medium-term improvement plan for every dwelling type, and the employment of retrofit coordinators as required by past 2035. We'll come back to the process in a few minutes. We should be thinking about SAP 80 as our affordable warmth standard to give us headroom to protect against rising fuel prices. We should be thinking about passive house ENERFIT for energy performance where appropriate and affordable, and we should certainly be using the MCS standards for any of our renewable energy systems. So to summarize this part of the talk, we need to improve the whole building envelope to reduce heat demand and provide affordable warmth. We need to improve the building services to satisfy demand efficiency, to remove fossil fuels, and to achieve net zero carbon ready by 2035 or 2040. And then we need to top up with renewable energy systems to achieve net zero carbon by 2050. And throughout, we should be adopting best practice standards. We don't have time to retrofit our housing stock twice. So now I want to move on to a housing assessment methodology to support that strategy. And this is in 5 stages. And I'll go through each of them in turn. So the first stage is to make an initial stock assessment, using RDSAP data from housing stock condition databases, supplemented by more survey data if necessary. And we need some individual SAPs calculated, and we need some stock level KPIs, housing stock profiles, KPIs based on SAP, environmental indicator, fuel use, fuel costs, and carbon dioxide emissions. Stock profiles down the bottom of the screen there. Key performance indicators might be average and minimum SAP and EI, and average and maximum fuel use, fuel costs, and carbon dioxide emissions. Second stage is to identify dwelling types within the stock. We can filter the housing stock data by age, by built form, and by heating system type to arrive at a set of types. Usually, once we've refined that filter a bit and put some local knowledge in, we can get to a set of 25 to 30 dwelling types in a typical social housing stock, including ground, mid, and top floor variants of flats. And we should know how to assign every single dwelling in the stock to one of the types. And then we need a representative example of each type, for which we must have EPC data, so we've got full SAP data or potentially full SAP data, and photographs, which we can check with Google Street View and things like that, in order that we can move to the third stage, which is an improvement option evaluation, as required by PAS 2035, but basically figuring out what does the dwelling need, what measures do we need to apply to it. First thing you need to do that is a schedule of capital costs for all your improvement measures. We're building those. We have one at Savills, I have one, and lots of housing organisations are beginning to build up robust schedules. For each dwelling type, we need to assess its performance as existing and calculate the performance indicators. And then we need to evaluate improvement options to achieve SAP 80 first, and then net zero carbon ready, all as required by PAS 2035. For each dwelling type, we then need to establish an improvement plan. What are we going to do to this dwelling type? Again, as required by PAS 2035. What measures are required at each stage? What is the capital cost of the package of measures we're proposing? And what will be the improved performance at the end of the process? Here, just for illustration, is a cost file, not very informative really, but it's a list of measures with, in the yellow column, agreed costs for each of those measures. Actually, their cost rates per square metre in this particular case, and a typical social housing cost file will run to several pages covering all the measures, including things like access, like scaffolding and so on. Here's the result of a first stage dwelling assessment. This is a house in Harlow that we looked at a few years ago as part of their stock. And here we have the ratings of the unimproved dwelling at the bottom of the screen, the SAP, the EPC, the SAP CO2 emissions, and what a 50% reduction would be, because at the time we were doing this work, net zero carbon ready was about 50% reduction in CO2, we thought. And then there is a table which breaks down fuel use, energy use, fuel costs, and carbon dioxide emissions by end uses. So we're getting ourselves detailed information about how this dwelling performs. Here is an improvement option evaluation. This is a table of measures down the left-hand side to be applied to that particular dwelling with their capital costs from the cost file, or calculated from the cost file, because the cost file contains rates, and then with the fuel cost saving and the CO2 saving in the right-hand columns, and at the bottom of the screen here, the improved performance. Again, fuel use, fuel cost, carbon dioxide emissions broken down by end use. Step 4, having done that work for every dwelling type, is to scale up to stock level. So for each dwelling type, we apply the identified improvements to every dwelling of that type. And then we can recalculate the individual SAPs and stock level KPIs. So we can recalculate our housing stock profiles of SAP, EI, fuel use, fuel costs, carbon dioxide emissions. We can recalculate our energy performance indicators, our key performance indicators, and we can calculate the overall improvement cost for the stock of applying the package identified for each dwelling type to all dwellings of that type. And we can break down the results of that work in lots of ways. Once we've done that, we can start to establish an investment strategy. We can look at our improvement costs. We can identify improvements that are already budgeted for, or perhaps ones we can take out of the current budget, like boiler replacement. We can identify potential external funding, like ECO or other grants. We can consider the integration of the improvement program, of the improvements with other programs in the organisation, embracing energy efficiency and planned improvements. So that might include integrating separate programs for opportunist work, energy intervention, emergency intervention for fuel poverty, shovel-ready plans for external funding, and then an integrated, coordinated whole dwelling improvement approach. And then finally, we can develop a detailed net zero carbon investment plan for the stock. And here is a summary of improvement costs by dwelling types. The left-hand column, ABC, is the dwelling types in the stock with descriptions, a number of options perhaps for some of them. And then we have in each case, we know the number of dwellings, we know the cost of SAP 80, we know the cost in this case of getting to our carbon reduction target, which is 50%. We know we have overall additional cost of doing both, and then we can work through and add up all the costs across all the parts of the stock. And here we have a breakdown of improvement program by measures. So that's telling us how much we have to spend on each of the different things we might want to improve. So we have scaffolding, and then we have floors, walls, roofs, and so on, windows, doors, and heating systems. And to get to SAP 80 for fuel poverty, for affordable warmth, we've got these costs. To get to, in this case, carbon 50, we've got these costs, and the overall carbon 50 cost, which is the two added together, is in the right-hand column. And you can see that we get eye-watering totals, £120,576,000 to do this particular stock to a 50% reduction in carbon emissions. So that's the end of my talk. Happy to take questions during the question session. And we now move on to the next speaker, I think.